Reactions in aqueous solution. Acid reactions. 3.4 acid and base titration. Here we have equipment we're going to use for a titration. These are two burettes. In this one we have sodium hydroxide solution, and in this one we have sulphuric acid. I know the concentration of this one. I'm trying to find the concentration of this one. We start by putting some of the hydroxide in the conical flask. I have taken the reading at the top. Let's just run a little bit in. We can see the graduations start at 0 and it comes, the numbers get bigger as we go down. So I now have put in, and notice I put my head level. I've done 15.6 cubic centimeters or milliliters of the base has gone in here. So I use some bromothermal blue indicator, and you can see why it has the name now. Gives a nice blue color in base solution, an alkaline solution. Now I'm going to add some acid to it, and we'll see what happens. You will see in the middle it changes color to a yellowish. When I swirl it, I've now added more acid than I had alkaline. I can now go back and add some more alkaline. Now some more acid. Now I want to try and get it till I've added an equal amount. The best technique is for me to put my hand like this. Notice the tap is off when it's at right angles to the tube. Now if I do that and I turn it in one direction, I can add small amounts. It has changed color. Let's try that again on this side. A little more acid. And we can go backwards and forwards until we get it a nice greeny color. I can also add a drop very carefully. And there we're getting a nice greeny color, which means I've added an equivalent amount of alkaline to acid. The titration calculation. 2 sodium hydroxide units plus 1 sulphuric acid reacts to form, they neutralize each other, 2 water molecules and a sodium sulfate unit. Remember that these substances have ionized. Sodium ions, hydroxide ions, hydrogen plus ions, and sulfate ions. These two, the hydroxide and the H plus ions of the acid, neutralize each other, thus forming the water molecules. This occurs in a 2-to-1 ratio. So at the end point, the equivalence point, when you've added an equivalent amount of acid and base, the number of moles of the sulphuric acid is half the number of moles of the sodium hydroxide. And since concentration is number of moles per decimeter cubed, the number of moles is the concentration times the volume. So if we have the number of moles, concentration times volume of the acid is equal to half that of the base. Now, our titration values were as follows. We started off with a standard solution of sodium hydroxide of concentration 0.196 moles per decimeter cubed. In the titration itself, the burette values, we subtract the top value, the small one, from the bottom value. We get 16.2 for the volume of the base, and similarly for the acid we get 12.3. So, plugging those values into this formula results in this calculation. giving us an answer of 0,129 moles per cubic decimeter for the concentration of the acid, the sulphuric acid that was in the burette.